Have you ever pondered the existence of parallel universes? Picture this: an infinite number of universes, each one slightly different from the last, all coexisting in the vast expanse of the cosmos. This isn't just science fiction. It's a theory that some of the greatest minds in physics have proposed, known as the multiverse theory. Now imagine a universe where everything is mirrored. Positive is negative, left is right, and time flows backward. A universe where, instead of you pondering on the existence of parallel universes, a parallel version of you is doing exactly the same, but in reverse. The late, great physicist Stephen Hawking was one of the many scholars who believed in this concept of a multiverse, a grand tapestry of universes, each unique in its own way. At the heart of this discussion are cosmic neutrinos, elusive subatomic particles that zip through space at nearly the speed of light. They're like the postcards of the cosmos, carrying messages from distant galaxies and supernova, and they hold the potential to unlock some of the greatest mysteries of the universe. But is there any evidence to support these mind-boggling theories? Enter the ANITA experiment. Imagine a giant balloon with multiple satellites and radio antennas, scanning a frozen landscape larger than 1,000,000 square kilometers in search of cosmic life. This isn't the plot of some science fiction movie, but the real-life mission of NASA's ANITA project, or Antarctic Impulsive Transient Antenna. The goal of the experiment was to shed light on the mysteries of the cosmos by detecting high-energy elementary particles known as cosmic neutrinos. These elusive particles are capable of passing through solid matter, making them incredibly difficult to study, yet potentially revealing about the universe we inhabit. Despite the grandeur of the mission, the initial results were, to put it mildly, underwhelming. After several project runs, the scientists were left with no significant findings. It seemed like the massive balloon, making its third trip scanning the Antarctic, was failing to deliver the groundbreaking discoveries it was designed for. But then, something unexpected happened. As the team reviewed the results of the first 2 flights, they realized they might have overlooked something crucial. What they had previously brushed off as mere background noise and interference began to take on a new significance. The team had detected a phenomenon that neither physics nor astronomy could readily explain. The cosmic neutrinos they were hunting for had been there all along, hidden in what was thought to be just noise. Many of these neutrinos behaved as expected, radiating from space and striking the Earth from above. But some of them seemed to be doing something quite peculiar. They were moving from the ground upwards, as if emerging from an explosion within the Earth itself. This was an event that seemed to defy the laws of physics, with the neutrinos seemingly moving backward. Could this be a sign of a parallel universe where everything is mirrored, positive is negative, left is right, and time runs backward? What was initially dismissed as mere background noise and interference turned out to be a potentially groundbreaking signal. The researchers became witnesses to a phenomenon that baffled both physics and astronomy. This conundrum was none other than the unexpected behavior of cosmic neutrinos discovered during the first 2 scans of the ANITA experiment. For those who might be wondering, neutrinos are elusive particles that rarely interact with matter, making them incredibly difficult to detect. But here's where things get truly intriguing. Some of these neutrinos were behaving in a way that seemed to contradict the laws of physics as we know them. Instead of moving downwards, as one might expect from cosmic radiation hitting the Earth, these particles were moving upwards. It's as if they had emerged from an explosion in the ground and were defying gravity. A scenario that simply shouldn't be possible according to our current understanding of the universe. So, what could explain this unusual behavior? Some scientists have proposed a theory that sounds like it's straight out of a science fiction novel. They suggest that these backward-moving neutrinos might be evidence of a parallel universe. In this theorized parallel universe, everything would be reversed. Positive would be negative, left would be right, and time would run backward. It's a concept that challenges our perception of reality and opens up a myriad of possibilities. If true, it would mean that there could be an entire universe existing in tandem with our own. operating under a completely different set of rules. So, could the backward movement of neutrinos be evidence of a parallel universe? And what about the backward-going radiation found in the Antarctic ice? These are questions that scientists around the world are still trying to answer. The answers to these questions might just redefine our understanding of the universe, or should we say multiverse, as we know it.